Alright, we are down to the last four videos. It was fun while it lasted. But yeah, and this is the last video of the assembly segment. I hope there's going to be three more lectures, but they are not going to be assembly. So yeah, let's get started. So today we are basically going to look at how the stack works and how pointers in general work in assembly. Um, because so far you have seen how the normal variables work and um, what else, and how function works, how loop and if else statement works. So you already know those stuff. Today we're going to see how referencing and dereferencing works. So let's get started. The first thing we're going to take a look at is this function. So in C, it's pretty straightforward. As you can see, we're just like putting x and like values to x and y. Then we are going to use a pointer. This pointer p1 is actually pointing to the address of x. p2 is pointing to address of y. Then p3 is pointing to address of p2, which is here. We are going to use a variable AA and put the value of P1 in this case, which is 42, and put it in AA. We are going to put the value 10 in P1, so the value of X is going to turn into 10 afterwards. And then we are going to get the value of P3 dereferencing twice, so it's basically going to go to here first, and as we can see it should be going here and then going to get the value of y. So usually you won't be doing that, but like yeah, pointer of pointer is a thing, right? So yeah, then we are going to get the value of 99 and put it in bb. So that's pretty much how this function works. So let's see how it looks like in assembly. This is how it's going to look like, and I'm going to get there one by one, and this is how our stack is going to look like. So one important thing over here is like, okay, so the pattern of how the variables are going to be put in the stack is not predetermined. Okay, so it's true that whenever you run this code by yourself, the stack might always look like this, but it doesn't mean that there's any sort of convention. But a few things are there to notice. For example, we always start from RBP, right, and do something like RBP minus 4, but this time we are actually doing RBP minus 8, because in this case it's P1. P1 is a pointer, right? So it needs 8 bytes, because that's the length of our address. So that's why we're doing RBP minus 8 instead of RBP minus 4 like usual. The same goes for P3. We are doing RBP minus 16 because the difference over here is 8. For AA, it's a normal variable, so the difference over here is only 4. So we are doing minus 4 over here. BB is also the same, so the difference is 4. X is also 4. Y is also 4. But P2 itself is a pointer, so it needs 8 bytes. So this difference is 8. So that's how our stack is looking like, and we are going to take a look at how the assembly looks like step by step. Okay, so the first thing happens is we are putting some values on x equal to 42, y equal to 99. So this is very simple. You have already faced that, so you know how it works, right? We are just moving the value over here, and minus 28 over here is x and minus 32 is y. Then the next one, so we are going to use load effective address, which is LEA. This is a new command you're going to take a look at. This one deals with the address and all of those. Okay, so the command we're going to try is p equal to pointer x. So we are going to get the address of x. So to get the address of a variable, what we do is use EA, and in this case Q, because it's going to be 8 bytes because it's an address. Okay, and because it's 8 bytes, we are using RAX instead of EAX. Okay, because EAX is 4 bytes, which is the same size as an integer. But right now we are dealing with address, so we are going to use 8 bytes. Okay, or 64-bit, however you wanna um, think about it. So yeah, we're going to load the address of minus RBP, which was X, and then we are going to put it into RAX. Then we are going to get that address and put it in a variable, which is P1, because P1 is in our RBP minus 8. So we are going to get the value, like the address of X, by doing load effective address and going to put it into RBP minus 8. So this is what just happened. The same happens for P2 equal to pointer Y, like ampersand Y. I don't know why I was saying pointer. So anyway, we are going to load the address of Y and put it into RAX, and then put the address in our RBP minus 40, because RBP minus 40 was P2. Okay, I hope this makes sense. Next we are going to try is we are going to get the value of address of P2. P2 itself is a pointer. Now we are going to get a address of a pointer of a pointer. Okay, so the first thing we are going to do is load the address of RBP minus 40, which was P2, and put it into RAX, and then we are going to take the value and put it inside RBP minus 16, which is over here. Okay, the next thing we are trying to do is going to access the value of P1. Okay, the value that P1 is pointing to, which was basically X. Okay, so let's see how we are going to do that. The first thing we are going to do is move the value of P1. Our P1 is in RBP minus 8. So we are going to get the value of P1 and put it into RAX. Then what we are going to do is do this. If you recall the first like introduction to assembly and stuff, this bracket usually means that I want the value that this address is pointing to. In this case, RAX is actually holding on to a value RBP minus 28. So by doing this command over here, we are telling our OS that I want whatever is being pointed by RBP minus 28, which is this place, right? And this place actually points over here. If you remember the previous slide over here, so yeah, so it's pointing over here, and then we're going to get the value and put it into RBP minus 20. RBP minus 20 is basically AA. Okay, I made a mistake over here. So okay, I made a mistake. Okay, my bad. So yeah, the first thing is going to happen is we're going to take the value of P1 and put it into RAX. By doing this, we are getting the value that's pointed by RAX, which is actually 42. And then we are going to take that 42 and put it inside RBP minus 20. Okay, so this is basically what happened. I went ahead extra step and I made a mistake there. So yeah, that's what happened. And by doing something like this, RAX, it's basically telling the OS that I want any value that's being pointed by this. If we wrote this only, it would print us the address of X, like printing X like this in printf, and doing this is the same thing. But by doing this, we are actually doing something like this. Okay. This one is much easier than the previous one because there is no in between pointer. So let's see what happens. So we are going to take the value of RBP minus 8, which is this P1, and then put it into RAX. Okay, then we are going to dereference it and go, is it dereference or reference? Yeah, technically it is. So yeah, we are basically doing something like this: pointer of P1 or RAX and putting 10 inside that value. So this part of the C code is basically like is being done by this. Like this part of the C code is being done by this. Okay. Okay, so this one might be a bit complicated, but I'm pretty sure at this point you should be pretty familiar with how pointer and pointer of pointer works. So what we are going to do is get P3, dereference it once, then dereference it again. So if you put together the things you have seen just in the previous slides, you can do it by yourself. So but I'll still show you around. So our P3 is actually stored into RBP minus 16 at the beginning of the assembly, right? So we are going to take that value and put it into RAX. Then we are going to dereference RAX once and put it into RAX. Okay, so we just did this part as mentioned over here. Then we are going to do RAX again, and then we are going to put it inside EAX. So we are doing this, and I don't know if you noticed that, but like over here it was a quad, but over here it's a long. The reason it's and not just that, we are using EAX instead of RAX because RAX is a 8-byte, but we over here, like after dereferencing it twice, we are actually working with an integer, and integer in this case is 4-byte, so we do not need a quad. That's why we're using long. Okay, then we are going to get the value and put it into RPP minus 24, which was BB. So yeah, that pretty much sums up the whole how the pointer and pointer of pointer and addresses and all of those work. Please let me know if it didn't make sense to you. Okay, moving on to the next function. This is another very simple function in C. So we are going to send a array and its size as a parameter, like 2 parameters. First we are going to check whether array is null or not, like if the address is valid. Then we are going to go through the array one by one till it reaches the size and put some random value within 124 and put it inside the array. Then we are going to return the size, and we are not returning the array because whatever array you send as a parameter in a function, it like changes throughout the whole thing, right? So yeah, let's see how the assembly of it looks like. So yeah, um well, it's actually explained step by step in the later slides, but I'm going to show you it right away. So once again, okay, you may be wondering what are stored here. Sometimes these are just like empty spaces. Okay, and this part, like using the stack like this, sometimes this is the decision of the compiler itself. So there usually is no convention, and the only convention is like how much byte it needs. For example, size is 32-bit or like 4-byte, so the difference over here is 4-byte. Okay, so that's all the um, all the conventions there are, but like where they're going to be put into, like where the parameter is going to be or where the variable is going to be, it's not actually predefined. The way you know that something is a parameter is by looking at RDI and RSI, and the way you know it's a variable is by um, like looking at the difference, like is it like -4 or something like that, or yeah, like usually if it's using this registers, then you know that it's a parameter, okay. But otherwise, if it's using RBP directly, like RBP -4 or RBP -40, then in that case you know that that's a local variable, okay. So yeah, and over here the first thing is being done is we are checking whether RBP -40, in this case the array, is equal to 0 or not. If it's not equal to 0, then move here. Otherwise it's going to put 0 into the return register and then do a jump to L3, which is over here, and L3 is basically the end of the function, okay. So what happens in L2 is it moves 0 to RBP -20, which is our local variable x. In this case, we're putting 0 over here, so it's basically executing this part, okay. Then we are going to jump to LO4. LO5 over here is the body of the for loop itself, and LO4 is basically this rest of the part, okay. So this is what a normal for loop looks like. So yeah, in LO4 we have like move RBP -20 and put it into EAX. We are doing another comparison, so basically we are doing this part and we are checking whether it's less than size or not. Over here the size is put into RBP -44 over here. If it's less than size, then move to L5. Otherwise put the size inside EAX and do a return, because we know that whenever we want to return something we put them inside the register EAX, okay. So that's pretty much the for loop of it. So let's see what happens to the rest of the code, okay. I just explained all of this, and yeah, this slide is actually for your understanding, and I already showed it to you, so it depends on like how you want to go with the slides, okay. So this is what the body of the for loop looks like, okay. So we are going to take a look at them one by one. So I'm going to go back and forth, like over here, look at this code and explain what just happened. So bear with me, okay. So the first thing we're going to do is move RBP -20 and put it into EAX. In RBP -20 we had our variable x and put it inside EAX. Then we are doing something like load effective address. We are doing 0. Over here it's empty, RAX4 and RDX. So I'm going to explain how load effective address works like this in the next slide over here, but bear with me. This is something similar to this. So by doing this we are actually calculating how farther we have to go in the array to find our index, because we are doing something like array x, right? So to do something like array plus x, like it goes that many places, but remember that part is done for you in C directly, but assembly is actually showing you how it is done in C, so that's why it's being broken down, okay. So by doing this we are actually making sure that we get that specific index of the array, okay. Then we are going to move RBP minus 40 into RAX. Okay, we are doing this. So this one is definitely an address, right? Let's see what it was. It's an array, and we know that array is actually the beginning of the address of an array. Okay, and we are putting it inside RAX. Then we are doing another load effective address, and over here we are doing RAX and RDX. We know that we calculate the value of x and put it inside RDX, and RAX is the starting point. So by doing this, we are doing basically array plus x into size of UN32. So the whole calculation of where in the memory it's actually stored is done over here. So let's try to draw a picture about it. So it's kind of like this. In normal C, your array looks like this, right? This is the 0th index, this is 1, 2, and so on. Let's assume this is our array. So whenever we do something like a and mention like 1, is just pointed here, but how is that part happening? So remember, every integer is 4 bytes, right? So it has to make sure that it moves 4 bytes every time. So that's why this 4 is here. It is actually telling the OS that I want to move 4 bytes every time, and this is 0 for now. RAX is going to change every time because we know that we are getting the value of RAX thanks to this part, and in this part we are getting the value of x and putting it inside EAX. We know that in our loop there is a x plus plus, so this value is going to change. We see that over here. Okay, so every time RAX is going to move one place at a time, but then we have to calculate, like we basically have to multiply it by 4, and that multiplication is actually done by this. Okay, I hope that made sense. I tried my best. Okay, so yeah, and over here is basically doing something like a plus 1 dereference, and then get the value of RBX. Okay, that's basically what happened in this part of the code. This rand modulus of 124 is being done. Don't worry about it. This is out of scope for this course, like how these functions are being called. You will learn more about it in 2506. Then remember, like, it's the rand is going to return something, right? And that value is going to be stored into EAX. Then we are going to take that value of EAX and put it inside the address that's being pointed by RBX, and that part we calculated over here. So by doing this, we are actually making sure that the return address modulus by 124 and is being put over here. So over here we are just like doing something like array x equals this. Okay, and then over here we are just adding 1 to the x, like we're doing x plus plus. So this is what our assembly code looks like. If you have any questions, you can ask me later on, but like this is the whole idea of how it's happening, and this actually shows you like how the address is referenced in assembly. Okay, I hope I will try my best to not make the exams this complicated, but there might be a question about how pointers work in assembly. So please try to understand this concept clearly. Okay, I mean, I did my best. I don't know how else to say it, but like if you have any questions or confusion, you can just like clear it up by talking to me. So yeah, the comment we used, LEAL, L means long, you already know that. So what's over here being done is basically by writing it like this, we are doing something like this. I already explained to you how it works, but like this is a like more formal definition of it. And the last example with functions and pointers. So we are going to take a look at like how or why the call by reference works. Okay, because the pass by pointer protocol provides a call function with ability to modify the value of the caller's variable. This is literally why we use call by reference, right? So let's see why that works. Yeah, you already know how it works, right? Like who they are pointing to or something like that. So yeah, so the first thing that happens is in swap we are getting two parameters, right? I told you whenever there's parameters you have to take a look at RDI and RSI. So by RDI we are getting RBP minus 24. Over RBP minus 24 we are storing X. RBP minus 32 is storing Y. And as you can see, the difference between them is 8 because they are addresses, like each of them are addresses, right? Then we are doing this, move RBP minus 24 and put it into RAX. Okay, what does that mean? We are just getting the value of, sorry, we are getting whatever is stored into RBP and putting it inside RAX, and then we are doing something like RAX dereference and put it into EAX. So what happens over here is whatever is being pointed by X, get that value and put it inside EAX. Okay, then we are going to get the value of EAX and put it into RBP minus 4, which is temp. Then we are going to get the address of, because this is holding the address of Y, right? Address of Y and put it into RAX. Then we are going to dereference, which is going to point to 200 over here, like the value, like the variable Y. Okay, we're going to get that value and put it inside EDX. Then we are going to get RBP again and put it into RAX, and then we are going to get the value of what we put here, so the value of Y, and put it inside whatever is being pointed here, which is X. Okay, then we are going to get the value of Y again and put it into RAX, and whatever was stored into temp we are going to put it inside EDX. Then EDX is going to be put inside whatever is pointed by RAX, in this case Y. So that's how the whole swapping thing worked over here, and then we're just going to leave. Okay, so that's pretty much how like call by reference works. I tried my best again. So yeah, and 3 more lectures are left for this course. Yeah, I kind of feel sad, honestly. But yeah, that's it for assembly. If you prepare your final exam till this part for assembly, you should be good enough. You don't have to know more about it, and this is also going to help you a lot for 2506. So yeah, I think that's it for this lecture. I'll see you next time. Bye bye.